Alrighty, we're live. Please stand. In the name of the Father, of the Son, and of the Holy Spirit. Amen. Saint Michael the Archangel, defend us in battle. Be our safeguard against the wickedness and snares of the devil. May God rebuke him, we humbly pray. And do thou, O Prince of the heavenly hosts, by the power of God, cast into hell Satan and all evil spirits, who prowl about the world, seeking the ruin of souls. Amen. In the name of the Father, of the Son, and of the Holy Spirit. You got some notes, please. We've got a change of gears. Any consolation, historically people have found this to be quite a bit easier on the brain than what we just went through. Although it's a little strange at first. The packet? Yeah. The one that we went through on Friday?
It's not right.
No, which packet are you talking about?
Well, we didn't have homework on Friday, but you gave us a packet.
That was the, right. That is not due yet. Put that on ice for a while. Yes, good question, thank you. Yeah, the one that, I got to you a copy of that. That was 14B, even odd function. Yeah. As a review, this is not the main topic of today. Here's a typical story problem with my patented lovely artwork. I think I did this example before. I'm going to change the numbers. You probably recognize my awesome artwork for this. And there's a bird on the top of a tree. And here I am with a high-tech telescope or binoculars or something, which tells me two things. First, the bird is at the very top of the tree. And second, I'm looking up at a 27-degree angle. You actually don't need very high-tech stuff for that. You can use a protractor if you want. Use a pencil and see how far up you're going. Now, you can assume for the sake of this problem that the tree is vertical, that it's not growing crooked. What I want to know, you also know just from walking it, that this was 250 feet away from the base of the tree. Can you find the height of this tree to 4 decimal places? Now, I'm almost positive we did a problem like this before. Hopefully, at least the bird looks familiar. But is there any possible way to get it? I didn't give you a lot of information. If I had given you the diagonal distance, you could use the Pythagorean theorem. But I didn't. Cruel human being that I am. So what can we do? Yeah.
Do you use tangent?
We could. What is tangent?
It's opposite of adjacent.
Tangent of theta is opposite over adjacent. Why would that be interesting for this problem?
Because we have theta and we have the adjacent side.
Yeah, let me just surgically remove this triangle. Here's the triangle they're talking about. We know that the bottom is 250, and we're looking for h. And we know that this is 27 degrees. We don't have a heck of a lot to go on, but does it make sense that if you change gears from, from algebra mode to trigonometry mode, they're at least talking about tangent? Because they give you one angle, and they're talking about the opposite side and the adjacent side. That does sound an awful lot like tangent. question. Tangent of what? Yeah.
Isn't it 27?
It is, 27 degrees. Equals what over what in this particular case?
Height over 250.
Right, h over 250. Does anybody happen to remember how to solve this thing? I want to find h by itself.
Multiply both sides for 250.
Right. Think of it as an algebra problem, and multiply both sides by 250. Be careful. Do not multiply 27 by 250. This is input, this is output. Just leave it. Leave it as 250 times the tangent of 27 degrees. And that's equal h. My question is, how much is that? He says as he goes to grab his calculator and he, like a silly button, multiplier. This will also be a test to see. Grab your calculator. This, again, this chapter, you will need a calculator for some of these problems. It will be virtually impossible unless you have a brain that's way, way more like God-like than any of the rest of us. So, what do you think? Let me double check and make sure I'm in the right mode. Yep. May I have an answer? Yeah, go.
127.4.
Correct. And give me 4 decimal places. So 127 point,
3813.
close, 381.
14.
Yeah, it was 381,362, blah, 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 blah. And then look at the next digit and it rounds from there. So 127.3814. 127.3814 what? Yeah.
Feet.
Feet. We were using feet as the units here. We're using feet as the units here. Congratulations, you have just used trig in a sort of real life problem. This is much more comfortable and realistic than trying to climb the tree with a tape measure. I told you about that, didn't I?
Mhm.
Yeah, which is my misadventure with. I wasn't actually trying to measure the tree, I was just climbing the tree because I was an idiot. I was like 8 years old. And yeah, the top started to like bend a lot when I got really close to the top, which was super. That's when I kind of discovered that I have pure pipe. So, but I digress. Make sense? Think you could do a problem like this on the test? That gets you? Now, this is a review of old-fashioned SOHCAHTOA. If you have a problem where you can match it up with sine, or cosine, or tangent, you can do this. And it's not too horrible. You need a calculator for, if you have an uncommon angle, you've got to use a calculator, as far as I know. But, what if I gave you something like this? Oh, make sure this is it. Find X. Go ahead and write it down. Go ahead and draw that. This is one of our tasks for today. And I'm curious what you think of it. Not emotionally, but I'm sure it's it. Mr. Goggin, thank you for asking. I'm totally sick of this. No, that's not where I was going. But does anybody see anything that's a little bit wrong? Yeah.
There's a 90-degree angle.
Yeah, it's not a right triangle. One of the things that's an absolute requirement for SOHCAHTOA, right triangles only. Oops. Exciting activity point. If you don't have a right triangle, you don't have hypotenuse. Yeah.
Sorry, is that an exponent of 11 or is that inches?
Oh, sorry. This is inches. I should actually write that. Not be lazy. Yeah, 10 inches. 32 degrees, 21 degrees, x, and then 10 inches. So the bottom is going to be x inches. I still don't know what it is. I want to find x. Well, we have a serious problem here. It looks like I can't because it's not a right triangle. So are we doomed? Not yet. Yeah, great.
I she went, never mind.
Okay. I would love to try some sort of SOHCAHTOA trick. Maybe we could. Maybe. He says with a suspicious clearing of the border here. The best and most useful mathematicians in all of history were the sneakiest ones. Well, Pascal Matthews used to say that. Yeah.
Can you like turn it into a right triangle?
Possibly. Let me redraw this thing. If this is 32 degrees, I'm about to call on your geometry knowledge, or geometry remembering people. 100 degrees. I'm going to put 10 inches inside here, so I'm not going to run over. And this is x. I can only use SOHCAHTOA on a right triangle, and I don't have a right triangle. Is it possible to get one? Well, let's start from again. Is it possible to draw one based on this? Using the equipment you already have, could you possibly, yeah.
So you're saying draw the right triangle?
Yeah, I mean, not just random right triangles out of nowhere.
So, could you like split it into two triangles?
There are at least 3 ways you can do a right triangle on this. Actually 4. One is if you split it like diagonally like this, you will make 2 right triangles, correct? Now, the part of the issue is if I do that, I have no idea how long this is and how long this is, or how long this is, or what angles these are. So it'd be in the middle of nowhere. But that is a good idea. Eventually, in some other problems, we will do that. This particular one, it's too many unknowns. There's another possibility. And it's what you might sometimes hear referred to as thinking outside the box. Yeah.
Could you add a channel to the target?
Actually, let me give you some, let's call this point A, point B, and point C, just so you know what to refer to. Go ahead.
You could put a triangle on the BC side.
A triangle, let's say you want to start at B.
Yeah.
What direction should I go?
Down.
Straight down. Go ahead and do that with a dotted line. And go straight across and make a right triangle. This is not going to cure all of our ills, but it's an interesting possibility. First question. Does anybody know how big this angle is? Don't be afraid to say no. Yeah, I don't either. I have the foggiest idea. Your brain is sort of saying, there must be some way to get it. Yeah. Yeah. That one? How do you get that? Sneaky. The angle inside is 127. Go ahead. Interesting. What's 180 minus 127? Yeah, a second. 53, correct. So this angle inside, let me just recap what that was all about. Does everybody see how I got 127? This first triangle that we started with, any triangle, all the angles add up to what? Anyway, 180. They always add up to 180. So if you have 53 degrees so far, then the rest, you take 180 minus 53. I might as well just draw that in. And you get 127. Now how do we get the 53 over here? Not the 180 from the triangle, but 180 from what we call a straight angle. If you have a straight line, how many degrees are there if you go all the way from one side to the other? Yeah. 180. A straight angle is 180. So if the 127 plus something is 180, do the subtraction, you get 53. Can somebody tell me the angle here? Yeah.
It's 37 degrees.
How do you get that?
Well, you know that it's a right triangle, so that's 90 degrees plus 53, which is 143.
Correct.
You subtract that from 180.
Exactly. So you've got a triangle here, the right triangle, is going to be 90 plus 53 plus No, I don't want to use X, I already used X. Yeah, I don't know, A. So, let's use let's use capital B. Yeah. Darn it, I don't know what to use. I'm gonna use Q and just run with it. Okay, so we now have 143 plus Q, and you know that that's equal to 180. Because any triangle is equal to 180. So 143 subtract, ta-da, you have 37 degrees. That's very interesting. Now, it doesn't tell us a heck of a lot about X. X is in a different triangle. But it's more than we had before, and maybe, just maybe, we can play with this thing now. I would propose to you, let's call this corner D. How many triangles do you see in this picture? This is sort of a geometry quiz, mental quiz. Go. There are 3 of them. Can you name them? Triangle, and name them by the 3 corners.
Yeah, triangle BCD.
BCD? Okay, just a second. BCD is this little right triangle over here. What's another one?
BAC.
Yeah, ABC or BAC, doesn't matter really what order. That's the original triangle. And where's the third one?
BAD.
BAD. BAD. That triangle, no thank you. No, that's not what I'm talking about. But do you see the 3 triangles? There are 3 of them, and we might be able to play with this. Now, I do not have X. I do not have, darn, I'm gonna have to invent more letters here. I'm gonna call this Y, and I'm gonna call this Z. I have no idea. Should I call that H? Actually, yeah, I'll call it H. Sorry, y'all writing in time, I apologize for. I should see it by the end of one of my lessons. Are you sure, Mr. Coughlin? Okay. Oh no, I'm gonna. I feel for you. I should do that. So, I want to find X, but there is no direct way to find X using this because it's not a right triangle. There are 2 right triangles you can pick from. Name them. What? Which of these 2 are right triangles?
BCD and BAD.
Yeah, BCD is a right triangle. That's the little one. And BAD was a big right triangle. Let me just draw these. BCD is over here. BCD. I would recommend you draw these in your notes somewhere. Kind of do them side by side. And here's the big one. So A, B, D. Okay. Fill in any measurements or letters that you have. Angle C, we found that was 53 degrees. Do the hard work of y'all. And then BD is H. We're calling this Y. And can somebody tell me how long BC is? Look in here and tell me, did they give us a length for BC? 10. 10 inches. That's useful. Now over in ABD, let's see what they have. It may not be as much, it may be more, who knows? Sam, take over. Did they give us a length for AD?
No.
No. What's the best we could do? What formula
X.
could you?
XY?
Sort of XY. If you take, let's just say this is 10 and this is 3, what would the length be?
18.
How'd you get that?
Oh, X plus Y?
X plus Y. Good. Anybody see anything else? Letters or numbers or formulas? Josh, how big is BD? It's H. Yeah, I don't know anything else. Do we have angle A? Oh, we're at it. 32 degrees. Do we have angle B? Look carefully. Yeah.
58 degrees.
How do you get that?
You had 21 degrees, 37.
You see the 2 little pieces? The upper angle B is 21, the lower angle B is 37. The overall one is 58. That's something. Kind of nice. Do we have the length of AB? Did they give us letters or numbers at all? No. It looks like we're stuck here, and this is all we've got here. Look carefully at those and tell me, which of those two could we possibly do any work on? Could we possibly get anything useful out of? Because sometimes they just don't give you enough information, you're stuck. Yeah,
Triangle BCD.
why do you say that? Yes.
Because we have one of the sides there now.
You have at least one side. Here, you're just out in the, drifting in the water without a paddle. Here, we've got a number. And I'm curious, if anyone can tell me how I could get any of those sides. Let's try H first. Is there any way we could possibly get the length of H? Given only what we have. And they haven't given us much. Second, if you were thinking trig, and I was thinking of 53 degrees, which angle is that kind of sort of reminding you of? Sorry, that was a stupid question. Which trig function is that kind of sort of reminding you of? It's reminding me of 53, but how do you like it? But, sorry. Which of the three trig functions might give us something useful? You could use all three of them, but only one of them has a prayer of being solved. Maybe. What is cosine? Adjacent over hypotenuse. Y over 10. By the way, that would work, but that would give you what letter? It would solve for y. What's for one H? By the way, we're going to do that later, maybe. But how do you get H? What trig function? Let's try tangent. What is tangent? SOHCAHTOA. Opposite over adjacent. Has to be sine. Let's try that. No, okay. So sine of what angle? Good. Is equal to whatever what? Got it. Can somebody finish this problem for me? How do you get H by itself? Yeah, multiply it by what? By 10. Grab your calculators, y'all. Well, actually, no, not yet. But soon. Have it warmed up. Please cancel. Somebody say that H is 10 times the sine of 53. Just leave it like that for the time being. We've just found the height. Now can somebody get me y? Maybe you can help me out. Start over again, and how would you find y? What trig function sort of kind of suggests that? Just ignore this stuff. Cosine. Cosine of what angle? Okay. Is equal to whatever what? Y over 10. How do you get y by itself? Yeah, multiply both sides by 10. Just cancel. So y equals 10 cosine of 53 degrees. Interesting. Do we have, let me see. I want to find x. I have y. Let me draw what we have so far. I realize I draw 8 million pictures. But here's the original ABD. We have H, 10 sine of 53 degrees. It's horrible, but yeah, just read it. It's going to be an even worse decimal, so just leave it as is. And then on the bottom, can somebody tell me what the length of that was again, John? X plus y. Now you can give me a formula. You can't give me the whole thing, but you can plug in one part. What would you have so far?
10 cosine of 52.
Yeah, does everybody see where that came from? X plus y is x plus this thing. Getting better. I still don't know how long this is, but it doesn't seem to matter. Can somebody refresh my memory what this angle is? 58 degrees, good. Why would I care? We can find a trig function to match it. Which trig function seems to use this side and this side if you're aiming from this angle? Sine, cosine, or tangent? Well, let's try it. Sine is what? Opposite over hypotenuse. And they don't give us hypotenuse. Tangent. Tangent of what angle?
58 degrees.
Okay. Is equal to what over what? And warning, this is going to look a little gross. Go ahead. Finish it off. What's the opposite side? It's big and ugly. No offense.
X plus
X plus 10 cosine of 53 degrees over what? 10 sine of 53 degrees. That's this part. Remember right so far? So this side over this side. Still okay? All right. I know this is my favorite problem. Come on, you will actually kind of enjoy this by the time you're done. I want X by itself. Switch on your algebra part of your brain. I want X by itself. Raina, you're on. What do you get rid of first? And I'll give you a hint. This is all welded into one big ugly decimal. So treat it as one big lump.
So, did you get rid of 10 sine?
Yes, get rid of 10 sine of 53. How? Multiply by it. 10 sine of 53. 10 sine of 53. What happens over here? Cancel. So we have x plus 10 cosine of 53 is equal to 10 sine, wow. This is sort of, somebody must have taken an axe at my board. 10, that's hard to write over. 10 sine of 53 degrees times tangent of 58 degrees. I haven't the foggiest idea what that is, by the way. No clue. One more step. Shelley.
You subtract by 10 cosine of 50.
Right. Subtract 10 cosine of 53 minus 10 cosine of 53. You should get, hold on to your hats, 10 sine of 53 tangent of 58 minus 10 cosine of 53 degrees, of course, equals x. Glory be to God, we have a formula for x. Grab your calculator. Let's put this puppy to bed. By the way, the thing I'm going to cover next, you're probably going to enjoy a lot more than this. I'll tell you what. But on if you have a display calculator, you can just type all of this in. Make sure you're in degree mode. If your calculator is one of those where you have to hit the number and then hit tangent or something like that, God help you. But let me know and maybe I can talk you through it. So 10 sine of 53, hang on, I got to catch up with you all. Times the tangent of 58 minus 10 cosine of 53. Let me get an answer. Give it to 4 decimal places. X is approximately what? Be brave. There should be a single digit followed by a bunch of decimals.
6.7627.
We got a winner. 6.76268 blah 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 blah, which rounds to 6.7627. Nice. Can somebody finish this off? 6.7627 what?
Inches?
Inches. Because the original one was in inches. You just found the mystery sign. Congratulations. That was a little on the brittle side, but you have to admit, the pieces fit together pretty well. Are you going to have to do that on the test? No. Why did I drag you through it? Because I wanted you to appreciate the formula I'm about to give you. Question? Yes. Leave the door cracked really good. So, let me try the same thing again, using a discovery made by a very smart person about 400 years ago. I don't quite know who it was. I've never been able to find a name associated with it. Please write this down. The law of signs. The law of signs. The only catch to the law of signs, it works on any triangle at all, not necessarily a right triangle. Right triangles are fine, but the law of signs is powerful enough to work on any triangle at all, not just right triangles. Please write this down though. Capital A, capital B, and I use little stems to represent capital C, because that looks a horseshoe. But that's just because, you've seen this, right? Did anybody tell me, is this a capital C or a lowercase c? Let me know. You want to take a guess? What does it look like? It certainly looks like a capital C. Are you sure? In other words, no. It's a relative term. You have to wait, but the little stems indicate a capital. So even though it looks like a horseshoe, especially if I draw them quickly, the capital C is there. The one thing I do want you to note, and this is the one thing you do have to remember, across from capital A is little a. That's a side. Across from angle B, down on the bottom, is little b. And across from capital C is little c. So just be aware that the letters are across from each other. A across from A, B across from B, C across from C. Make sense? You'll need that in order to make sense out of this formula. The law of signs states that this sum, doing capital letters. Sine of A over side A equals sine of capital B over little b is also equal to the sine of capital C over little c. In any triangle on Earth, that's true. Somebody did a lot of work and discovered this for us. I will note, it's only useful if we have a quote-unquote matched pair. I will be asking you that repeatedly, and that will be a best idea. It's only useful if we have a matched pair. For example, if you have A is 62 degrees and little a is 11 inches. In other words, if you have a side and an angle match, like you actually have numbers for both of them. Does that kind of make sense? So if A, B, and C are all unknown, you can't even use the formula. You have to have a matched pair. You have to have B and B, or you have to have C and C, or you have to have A and A. There has to be a matched pair, otherwise it's not even useful. It's still true, but you're left with a job. Yeah. Yeah, leave the door cracked. Let me draw this original triangle again. 32 degrees, 21 degrees, unknown angle, which we eventually found is 127. This was X. This was 10 inches. This was unknown. This is A, B, capital C. Question, can somebody tell me how big little a is? Is it given or not given? Kate. It's given, what is it? It's 10, yeah. Little a is 10. Did they talk about little b, Abby? It's X. Did they talk about little c, Courtney? No, they didn't even mention it, so don't worry about it. You can put C here if you want. Can somebody give me the law of signs? using those numbers? Please, help me out. Just recopy this, but fill in the information that we have. So sine of what? And A is what? Of an angle. Sine of 32 degrees over what? 10 inches equals, good, over x equals the sine of 127 degrees over c. That's all we have. I gently propose to you, if all we want is x, can we use this? Is it useful? In other words, do we have a matched pair? Taylor, where?
Sine of 32 degrees over 10 degrees.
Yeah.
10 inches.
We have a matched pair in this particular case. We have A and we have A. We should be able to use it. Let's do it. Does anyone remember in I think it was 6th or 7th grade? Do you remember how to do these? 2 over 3 is equal to 5 over x. Remember these? Yeah.
Isn't that cross multiplying?
Cross multiplying. So you get 2x equals 15, and then divide both sides by 2. And x equals I'll even do a decimal for everybody. Why? Because I usually hate them, but I suppose it's just as a gift to you because some of this stuff is intense. Look here. Can somebody get x by itself? Okay, help me out on this one. Just look at this part. How would you solve for x? You could, although there's a quicker way. That would work eventually. I could run this thing. Cross multiply. Tell me what you'd get if you actually did that. We'll do this times this. You don't have to put inches. So 10. 10 times the sine of the other one. Cross multiply. 10 times the sine of 21 degrees equals this. X times the. Yeah. Gardner, take over. Get x by itself. By what? I want x. But I want to get rid of what?
Oh, the sine.
Sine of 32. Punch that into your calculator. I think you'll find that a lot easier. So 10 sine of 21, close parentheses, divided by sine of 32. What do you got? Yeah,
I just have a question.
go ahead.
Sorry, you wrote this?
Okay, so can somebody give me the answer first and then I'll go back to you? Yeah.
6.763, wait, wow, 2.
7.62689.
6.762, wait.
So what is the count? Yeah. 6.762 what?
9.
It would have been if you got 5. This one. 7. There you go.
9.
Anybody notice something? It's identical. Exact same answer. Yeah.
So what does it mean, you might have already said this in my what does it mean to have a matched pair?
Oh, matched pair. Yeah. A matched pair is if you're filling in angles and sides, they have numbers for them. We actually have a number for this side. We do not here, and we do not here. So we have a number for this, side A. If angle A, which matches it, has a number also, then we have a matched pair.
So you just have to have all the angles?
Well, just an angle and its matching side. That's a matched pair. So if I give you if I knew how long side C was and I knew how big angle C was, that's a matched pair. Does that make sense? Everybody okay? That is the law of sines. Let me try another version of this. See if I can erase this out. This was the brutal version. By the way, the brutal version is how the law of sines was discovered. Somebody just put letters instead of numbers, cranked it all the way through, and eventually boiled it down to this, which was very nice of them. So we don't have to do all that grunt hard work. I wanted you to see it at least once so you can say that you've done it. Hey, I sort of kind of derived something that was really vaguely similar to law of science. So, and then now we can use the law of science forever and ever. Amen. Try this, quick example. Yeah, let's try another one like this. Let's call this side A, or angle A, angle B, angle C. This is side C, side A, side B. So here are the things I'd like to, side A, I'm going to declare as 20 centimeters. Too metric for a change. And then side C, I'm going to call 32 centimeters. And I'm going to say angle A is 10 degrees. And angle C I'm going to call theta. I would like you to find theta to 4 decimal places. Now, this is a little weird. Let me just strip out all the other stuff so you can see it without the letters. This is 10 degrees. This is 20 centimeters. This is 32 centimeters. This is theta. I want to find theta. It's not a right triangle. SOHCAHTOA is useless. You cannot use it. Not directly, anyway. Unless you want to do the big brutal method, which for nothing. Any ideas what we could do? If it's not a right triangle, we don't have much to go on. There's only one trick in our belt, so to speak. What trick is that? Josh? Law of science. We can only use the law of science if we have a matched pair, do we? The A's. Side A, angle A. We've got a matched pair. We should be able to get this to work. As a matter of fact, sine of, go ahead and do it. Sine of what? Sine of 10 degrees over 20 is equal to, look at B's. Did they give us anything for B's? Look up here, everybody. Everybody focus here for a second. We have a matched pair for A's, so I filled this in. You notice B and B, they gave us nothing? Skip it. Go right to C. Go ahead.
Should be sine of C.
Sine of, in this case, it'd be theta over what? Find theta by itself. First, how do you solve something with, it's called a proportion, fraction equals fraction. How do you solve those again? Yeah. Cross multiply. So write it like this, 32 sine of 10 degrees equals 20 sine of theta. All right, now what? Well, how do you get theta by itself? How do you get sine of theta by itself?
Is that 1?
That's 20, yeah.
So,
Divide by 20. Okay? So we now have sine of theta equals this 32 sine of 10 degrees, all divided by 20. I know you can reduce 32 and 20, but it's going to die anyway in a minute, so don't bother. How do you get rid of sine? Yeah.
Inverse sign?
We did a worksheet on this. This is inverse sine. But you have to do it to
Both sides.
both sides. I've got good news and bad news. The good news is the calculator is going to help you. Bad news is it can be a pain in the neck to enter. What happens when sine and inverse sine hit each other? Anyway, yeah.
I just have a question about the difference between inverse sine and
Oh, and cosecant?
Yeah.
Cosecant is when you flip the fraction upside down. Inverse sine is different altogether. It goes back, it doesn't give you a fraction, it goes back and finds the angle. Quick example. the sine of theta is equal to 1/2. Can anybody give me the cosecant? It's 2/1. What is the inverse sine? The inverse sine is very different. You're not plugging in an angle, you're plugging in the fraction and finding the angle that causes it. In this case, it'd be 30 degrees. In other words, it goes completely backwards. It doesn't find a fraction, it plugs in a fraction and goes back and finds the angle in the first place.
Oh, so it's just converting the
This is-
fraction to angle?
Kind of, sort of. It's saying what angle caused the sine to be 1/2?
Yeah.
And then think of the unit circle. Yeah, Gordon.
So why do we have to do inverse sine for this one, but for the other problem? we just-
Oh, good question, because we're trying to get theta by itself. Here, we were trying to get a side by itself. Here, we're trying to get an angle by itself. And it's not our fault, it was just the sine was glommed onto the theta, and we gotta get it off. So these cancel. So theta equals the inverse sine of 32 sine of 10 degrees over 20. You can do that on your calculator. Be careful when you put parentheses. The TI calculators are a little bit better at this than some other ones. Let me erase this thing. But with a little practice, you can get yours to work. And by the way, if your calculator is an absolute frustration pit, feel free to borrow one of mine. Those are all TI. So we have, here's what it would look like on an actual screen. Inverse sine of 32 sine of, and it'll probably give you your own parentheses, of 10, close parentheses, divided by 20. And it'll give you a weird decimal. Let me catch up with you all. So inverse sine. Everybody find out how to do inverse sine? Usually hit shift or second key or something like that. 32 sine of 10, close parentheses, divided by 20. What do you get? You want to risk their answer in public? Should be 2 digits followed by a decimal. Does that make anybody else braver? Yeah.
16.1312.
Yep. 16.1312. Question. 16.1312 what?
Degrees.
Degrees. Where is that on the unit circle? Just so we know. Quadrant what? Yeah.
1.
Quadrant 1. It's just a teeny bit beyond 0. 16.1312 degrees. I just have one more little funny business thing. This said that sine of theta, this original thing said that sine of theta is equal to 32 sine of 10 degrees all over 20. What is sine on the unit circle? Range.
Up
Up, down. Would you call that, I have no idea what this decimal is, but would you say it's up or down? It certainly looks up. Why? Positive. I mean, you'd have to type this in to be sure, but yeah, this is positive. And it's not very big. Just for giggles, grab your calculators. Type in the following. Just the inside stuff. 32 sine of 10 over 20. See what you get. 32 sine of 10, close parentheses, divided by 20. Can we get it? It should be some sort of decimal, 0 point something. And it's not very big. Yeah. Oh.
0.2778.
0.2778. That is how far up you are. I'll write that so I'm not going wrong.
This should come.
0.2778 like inches or something. Huh?
I got something that's just a little bit different. I got 2.2792491.
Let me see what you typed in. There are 2 possible reasons for that. One is a typo, and the other is a human reason. Oh, close the parentheses before you divide by 20. The reason I'm making a fuss over this says there's one angle that gives you that height. Is there another one? to tell me the number, just tell me the quadrant. What,
2.
quadrant 2? Can somebody find that angle for me? Because I agree, theta is equal to 16, but theta is also equal to this thing. There's a regular solution, and there's a shadow solution. We've been doing this a lot, like in the last chapter test. Like if theta is 30, theta would also be 150. It's on the same height. Kitty?
Would it be 163.86?
It would indeed. 163.8688 degrees. How'd you get that? Yeah, this is 180.
Interaction, any students needing a COVID test for athletics, please come to the office at your break. Thank you.
That's seriously scary.
Was it on
It's like it was right above my head. And it's
Was
going,
it on video?
where's that voice coming from?
It's recorded.
It is recording it. I don't know if I'm on screen or not, but holy mother of pearl. That was,
So delayed.
oh my word.
I got excited.
I was just in the zone and like, everything like deep in now. Please excuse the interruption. I'll send you a bill for my funeral expenses. Wow. I didn't need those 5 years off my life anyway. So, let me just wrap this up. Does it make sense that if one angle, the sine of this angle is up just a little bit, that there's another angle that's that high up? And if this is 16 degrees up, this is 16 degrees up. Start from 180 and subtract that 16, blah, blah, blah. You should get this. Let's go back to our picture. Let's wrap this thing up. Which of those two angles do you think is realistic? Just given the picture. They're claiming that this theta is either 16 degrees or 163 degrees. Which one looks like it's more realistic? Yeah. 163. 163. The reason I meant that, well, is it possible that it could have been something else? Maybe. We're going to talk more about that tomorrow. And yikes, I think we got to get hot with it. But have these two numbers in your notes. And that is it. There's no homework. The various people had to go catch up and sleep. Go past the humanities test. Please stand. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Let's go to the L. All right, see y'all later. Stay healthy and not heart attacky. Okay. People listening at home, see you later, and take care of your heart.